Our 8-1 notes will focus on parallel and perpendicular lines. Earlier in the year, we talked about parallel lines as two lines which never intersect, and perpendicular lines were two lines which intersected, forming a right angle. These are still true. However, today's section will focus on the slopes of parallel and perpendicular lines. For parallel lines, the slopes will always remain the same. So let's go ahead and write that in. I have an example in this box, so let's compare the two slopes for each line. When given a graph, we're going to calculate the slope by finding the rise over run. So using a graph, our slope will be equal to the rise over the run. So let's go ahead and find our two slopes. In our first graph, we're going to identify any 2 points on the line. So here are 2 points. Between these 2 points, it looks like I'm going to rise up 1 and to the right 2. So that means that my slope is 1 over 2. For our next line, we'll identify any other 2 points on the second line. So for example, I can pick this point and this point. It looks like for this graph, it also goes up 1 over 2. So my second slope is 1 over 2. Let's talk about perpendicular lines. For perpendicular lines, the slopes are opposite reciprocals. Once again, let's write this down. Opposite reciprocals are slopes which are flipped and opposite in sign. Once again, I have an example of two lines which are perpendicular. Let's find their slopes. So once again, since we have a graph, we're going to identify the slopes using the rise over the run. So I'll pick one set of points, or two set of points, from each graph. So from the first graph, it looks like we have a set of points here and here. So our rise is up 4 and over 1. So for our first slope, we have up 4 over 1, or just 4. For our second slope, we'll identify 2 points yet again. So suppose I identify these 2 points. My rise is actually -1, and my run is over 4. So my slope is -1 over 4. So if you take a look at these two numbers, and actually if you look at 4 written as 4 over 1, it's easier to see, you can see the flipped and opposite signs. 4 over 1 flip becomes 1 over 4, and the opposite signs means that one's positive and one's negative. This means that the two lines are perpendicular. Now we've talked about how to find the slope using a graph, but you can also find a slope using 2 points, and I think that's important to put in our notes. So on the side here, I'm also going to put using 2 points, we can find the slope using our slope formula. y2 minus y1 all over x2 minus x1. We'll use this later in the notes. So let's take a look at some problems. First off, determining whether lines are parallel or perpendicular. Step 1 is to rewrite the equations into slope-intercept form. Slope-intercept form, in case you don't recall from Algebra 1, is your y equals mx plus b form. It's the most popular form of an equation. The m indicates the slope, and the b is our y-intercept. For the purpose of these notes, we're mostly going to be focusing on the slope. And that's why we want to write it in our slope-to-intercept form so that we can identify that slope. And step 2, we're going to compare the two slopes to determine if they're parallel, perpendicular, or neither. Okay, so let's dive into problem number 1. Determine whether the lines are parallel, perpendicular, or neither. So the first thing we're going to do is make sure that each equation is in slope-intercept form. So if I take a look at my first equation, y equals negative 1/3 x plus 5, I see that it's already in my mx plus b form. The y is isolated by itself, and the x and constant term are on the right-hand side. So I can just pull out my slope from my first equation. And it looks like the slope is the negative 1/3, the coefficient in front of the x. For my second equation, I don't have slope-intercept form. So the very first thing I need to do is rewrite this into slope-intercept form. In order to do this, I have to get rid of any term on the same side as the y term. So I have to get rid of the 2x by subtracting it to both sides. Now be careful when subtracting 12 minus 2x because these are not like terms. And you cannot add or subtract unlike terms. So what actually happens is that they both stay. I'm going to write the x term first, even though it's the negative term, because we want it to look like our mx plus b form, so we traditionally put our x term first. Now, this isn't quite mx plus b form because the y needs to be isolated. Here we have 6 multiplied by our y. So to get rid of it, we're going to divide by 6, leaving us with y on the left. Now on the right-hand side, notice that I'm dividing both terms by 6. When you multiply or divide, you always have to be careful that you're multiplying and dividing the entire quantity. So I need to divide 6 to both the negative 2x and the 12. Negative 2 divided by 6 is going to be negative 2 over 6, or reduced negative 1/3. And then we'll go ahead and put the x in. 12 divided by 6 will leave us a y-intercept of 2. So here we have our second slope. The second slope comes from our mx plus b form now, and we see that it's negative 1/3. Comparing the two slopes, we see that the first slope and the second slope are identical. When the two slopes match, this means that the two equations are parallel. So my answer would be parallel, because they have the same slope. All right, let's continue on with 2 more problems of this nature. Problem 2, once again, we're going to start by identifying the slope in the slope-intercept form. Our first equation already is in slope-intercept form, so no work to be done here. And we just pull out the slope, which it looks like is 3/4. Our second equation is going to involve a little bit more work because it's not in our mx plus b form. We have to isolate the y by getting rid of any x term on the same side first. So let's add the 4x to both sides. 4x cancels on the left, leaving us with 3y. On the right-hand side, you could write this as 4x plus 0 or just 4x, your choice. I'm going to go ahead and write just plus 0 just to show you that it will be the mx plus b form. It's still not in our y-intercept form because we have the 3 attached. So once again, it's multiplied. So to get rid of it, we divide by 3. The 3's cancel on the left. On the right-hand side, we're going to divide through the 3 to both terms. 4 divided by 3 is a decimal, so we'll just leave it as 4/3 and it doesn't reduce. 0 divided by 3 is just 0. Now once again, the plus 0 is unnecessary for this problem, but I'm just writing like this so you can see that it is indeed mx plus b. So we see our second slope happens to be 4/3. Okay, so what is this? Parallel, perpendicular, or neither? Right away I notice it's definitely not parallel, because parallel, they should match and be identical. Here I see a 3/4 and a 4/3, so clearly those are not the same number, so they're not parallel. So are they perpendicular? They're definitely flipped. Is that good enough though? Well, it's not. perpendicular lines should be not only flipped, but also opposite signs. In this case, both slopes are positive. Since both slopes are positive, we don't have the opposite part of the opposite reciprocals. Therefore, these two lines are actually neither. You must have both opposite and reciprocals. Moving on to problem 3. So it looks like in problem 3, neither of these equations are in slope-intercept form. So the first thing I need to do is rewrite both of them into slope-intercept. In this case, I need to get rid of the 2x first by subtracting it. On the left, we get y. On the right, we have 4 minus 2x, which are unlike terms, so we'll just leave them separate. Yet again, writing the x term first, because that's traditional. Now our equation's in slope-intercept form, and we can identify our first slope as the coefficient in front of the x, in this case, 2. Negative 2. Let's take a look at the second equation. 2y minus x equals negative 6. Once again, not slope-intercept form. First thing we want to do is move the x term to the opposite side. So we add x to both sides, leaving us with 2y on the left. On the right-hand side, we have x minus 6. And last but not least, let's divide by 2 to isolate that y. Now, how do we do x divided by 2? Well, we always divide the numbers. The number, although not written, is a ghost 1. So 1 divided by 2 is just 1/2. And by the way, you'll notice I'm always leaving my slopes as fractions. That's because we typically like our slopes as fractions for several reasons. One, we think of them as our rise over run, our difference of y's over difference of x's. So just calculating them, we keep them as fractions. But not only that, by keeping them as fractions, you can see whether they're flipped versions of each other as well. If you put things in terms of decimals, it's hard to determine whether they are indeed the reciprocal of the other number. All right, constant, negative 6 divided by 2 gives me negative 3. So here is my second equation in its slope-intercept form. Its slope looks like it's 1/2. So are these parallel? Clearly not the same. But are they flipped reciprocals? Opposite reciprocals. Well, it doesn't necessarily look like 2 is the flipped version of 1/2. But if you think about 2 over 1, because you can always put anything over 1, you can see that 2 actually is the flipped version of 1/2. And not only are they flipped, they're also opposite signs. One's negative, one's positive. This makes these two lines perpendicular. Okay, let's take a look at our next set of problems. In our next set of problems, we're going to write the equations of parallel and perpendicular lines. Step 1 is to identify or calculate the slope of the original line. Step 2 is to find the slope of the new parallel or perpendicular line, either by finding the same slope or the opposite reciprocal. And then step 3 is to write the equation of the new line using the new slope and point. When we write the equation of a line, it's easiest to write it in point-slope form. So let's go ahead and review point-slope form. Here is our point-slope form of an equation. We have our m for slope, and then x1, y1 represents any point on that line. In problem 1, we want to write the equation of a line that contains 5, 1 and is parallel to the line y equals 1/5 x minus 2. The 5, 1 will be our new point, our x1, y1, when we need to write the equation of the line. We need to find the new slope. To find the new slope, step 1 says to identify the slope of the original given line. We see that the original given line is already in we see that the original line is already in slope-intercept form. So we can identify the slope quite easily, which is just 1/5. Next, step 2 is to find the slope of the new parallel or perpendicular line. In this case, the directions tell us that we want a parallel line. This means that our new slope should be the same. If the slope was 1/5, that means that it will remain 1/5. Step 3 is to write the equation of the line using the new slope and the new point. We're going to do this with our point slope form. Y minus y1 equals m times x minus x1. Okay, so let's go ahead and plug in what we know. Our y1 will be the y coordinate of our new point, so 1, equals our new parallel slope, 1/5, times x minus x1, the x coordinate of our new point, 5. And this is our line. If we want to simplify this into slope-intercept form, which I would suggest you practice doing because you never know what's going to happen on a standardized test and what form they're going to want you to write it in. If we want to write it in slope-intercept form, we need to distribute the 1/5 to both of the terms on the inside of the parentheses. That would give us 1/5 x, and then 1/5 times -5 gives us -1. After you've distributed your slope, you're going to isolate your y by adding the 1. And this gives us y equals 1/5 x, and -1 plus 1 actually gives us 0. So it actually cancels out the constant. And this is our simplified equation. Looking at our next example, we want to write the equation of a line that contains 0, -2, and is perpendicular to the line y equals -5x plus 3. The good news is that our equation is yet again in our sloped-intercept form. This means that we can easily identify the original given slope, -5. Next, we're going to identify the new slope. This time, we want a perpendicular line, so we need to find the perpendicular slope. This means we need to take the -5 and find the opposite reciprocal. Obviously, the opposite of a negative will become positive. But what's the reciprocal of 5? How do you flip 5? You think about it as 5/1. 5/1 flipped becomes 1/5. And this is our new perpendicular slope. Now we're going to use our new perpendicular slope and our new given point to write our equation of our line. Y minus y1 equals m times x minus x1. Y minus -2 equals our slope, 1/5, times x minus our x, 0. So once again, this is the equation of our line, but we could rewrite this into slope-intercept form by distributing the 1/5. 1/5 times x is going to be 1/5 x. 1/5 times 0 is just still 0. You can write plus 0 or you could just leave it empty. On the left-hand side, before I try to get rid of the -2, I'm going to rewrite this just as a +2 because it's easier to deal with a positive than a double negative. And we have to get rid of that 2, so it's positive now, so we'll go ahead and subtract it. This would give us an equation of 1/5 x minus 2. One more problem to take a look at. Here, we're going to consider two lines. Line AB, which contains the point 2, -1 and 0, 5, and line CD, which contains -3, 4 and 0, 3. And the question is, are these lines perpendicular? Explain our answer. This is like the first set of problems. We need to identify the slope of each line and then compare them. However, this time we don't have equations, we have points. So how do I find the slope of AB? When you're given 2 points, you're going to use the slope formula. y2 minus y1 over x2 minus x1. For A and B, you can pick either point as your x1, y1 and an x2, y2. So let's go ahead and plug in our point. Difference of y's would be 5 minus -1 over difference of x's, 0 minus 2. Simplifying, 5 minus a -1 is like 5 plus 1, or 6. 0 minus 2 gives us -2. If we simplify this slope, which you always should simplify, but leave it in fraction form, we get -3. Let's find our second slope. So we're going to find the slope of CD. CD contains these 2 points, so we'll again label them as our x1, y1 and our x2, y2. Using the same formula, difference of y's on top, so 3 minus 4, and difference of x's on the bottom, 0 minus -3, we get -1 over +3. So we get a -1/3. So let's compare these two values. Are they opposite reciprocals? Well, actually, they are reciprocals because 3 flipped is 1/3. But they are not opposite signs because they're both negative. So these are not parallel. So we would say AB and CD are not parallel, not perpendicular. And it also says that we need to provide a reason. So what is our reason? Well, because the slopes are not opposite reciprocals. In particular, they're not opposites. And that's the end.